Starting from our sample solution, let's take a look at the objective and what the final state might look like when we have our custom operand in place. Ultimately, what we want to be able to do is use our custom operand within the when clause to make scaling decisions. In this case, we want to say whenever our operand returns a value that's greater than or equal to 6, we want to take that scaling action. Our operand in this case is a simple dummy operand that looks at the last file count. You could use your imagination on what the source for this data is. It could be files in blob storage, files on a network share, or even files on a local disk. Right? And like for all operands, we are just referring to the alias here, where we're actually instantiating the particular operand within the operands element at the bottom of the rules file. In addition to instantiating it, we're also able to provide the standard set of attributes configuring it, such as the time span and the aggregate and the source. But we can provide whatever additional data that our operand requires, for instance, a connection string to Windows Azure storage, and have that passed down through the layers to the particular operand so it can do its job. So let's take a look at the implementation. Recall the first thing we need is the logic that knows how to interpret this XML file and return an instance of the operand. In our sample solution, we have the file count operand element that does just that. As you'll see here, we have our file count operand element that extends the data points parameters element class. And we've used the XML root attribute to give this the element name of file count. And that is what has to appear within the operands element in the rules file. Moving down, you'll see that we've defined a public property called connection string with a getter and a setter that we've decorated with the XML attribute connection string. This is what enables us to have the connection string attribute on the file count element within the rules XML. Beneath that, we have some static getters that return to us the name of the data point, in our case file count, the data point type, for us it's going to be in an integer because it's always a number, and the source name. In this particular scenario, we'll just say it's fixed source, but you would imagine you would describe whatever the source is, such as blob storage or file system, as alternative options. As we mentioned in the slide deck, when you override create operand, typically you're just returning a call to base.createOperand, so you can omit this method entirely if you're really not performing any value-added work. The crux of the class is this getCollectors factory method that we override and that returns a function. All we're interested in doing is returning a function that has a reference to an instance of our file count data points collector object instantiated with the information it needs to collect its data. In this case, the service information store, the connection string, what our sampling rate should be, the name of the source, the data point type, and the data point name that were provided from this class. Now, you'll notice that you can actually return an array of data point collectors. In our case, we return just one because we only have one data point collector in action. So what does the implementation of this class look like? Switch over to that. We'll zoom in, and you'll see the file count data points collector implements the iDataPoints collector interface. And what we have is our own public constructor that takes in all the information that we need to collect data from our data source. With that in place, the crux of the work is performed within the collect method, which, as you can see, takes in a collection time, which you could imagine you would use in the scenario where maybe you're constantly storing the data and you need to filter out a range of data that you want to return, so everything after the collection time or up to the collection time. And what you return is an IEnumerable of data points. In other words, all the data points collected within that period of time. So let's go continue with our imaginary file count, right? What we want to do is just pretend at this point we called out to, say, Windows Azure Blob Storage and counted the number of files in a particular container. Or went out to a network share and counted the number of files within that share. We set our value. And one important thing to be aware of is if you have any exceptions, not to throw the raw exception, but to wrap that in a data points collection exception. Finally, remember what you need to return is an array of data points. So we're only having one data point in this particular implementation, so we'll return a data point where the creation time and the data timestamp are the same now. The source is, our whatever we specified as the source name, and the data point name and data point type are what we passed in, and the value is the value 10 that we've hard-coded in this example. And that's all there is to it. We've created our operand element and data points collector. Now we're ready to plug it in and let Wasabi know about it. So to do that, in our host for the autoscaler, as in the console is a good example, in the app.config, to the rule store element, within the add element beneath that, we need to add an extension assemblies element that adds the assembly by name. We could do this manually, or we could do it with the edit configuration file. And what that looks like within the Enterprise Library Configuration console, if we expand autoscaling settings, expand the rule store, you'll see that all we're doing is putting the name of the assembly there, saving the file, closing it. Now we can go back to our rule store and use it just as we wanted to. And that's how we define a custom operand.